أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum warahmatullahi wabarakatuh. My name is Tanveer Khan and I'm a student of Mechanical Engineering Department, University of Indonesia, Lifo campus. So today I'm going to present my research article which title is Optimization of 2D element mesh and plane stress analysis of polycarbonate shell structure using the DiFi framework. So I will start from the abstract. So the abstract is um, explain few things: the objective statement, uh, um, topic statement, objective statement, methodology, and conclusion. So the topic statement is to optimize the 2D mesh configuration in polycarbonate element shell structure using the DiFi framework. Finite element analysis was used um, and methodology sections under the loading condition, static loading condition. Um, the input variable were uh, mesh sizes as well as the mesh method like mesh method, multi-zones, quadribe, quadrilateral dominant, and triangle. And the mesh sizes were taken as 1 mm, 2 mm, and 3 mm using ANSYS software. So the result obtained from this study, it shows that quad try method provide a balanced approach with high accuracy and computation efficient at 2 mm mesh size. So it means that it depends on the mesh method the as well as the mesh size as well. The quad try dominant method shows accurate result, but that took longer time. The triangle method give us the detailed result, but it also have taken the longer time than the quadri method. So this research article highlight the smaller miss increases accuracies, but it takes time. With using the DiFi framework, reflect an intentional approach to optimizations. So we use the DiFi framework to approach the problem to solve the problem to um, uh, to select the optimum combination of mesh size and mesh method, the best mesh method, so we can get the optimum result. The keywords are finite element method, 2D mesh, 2D element mesh, polycarbonate, stress analysis, DiFi framework, quad the mesh method like multi-zone quadrilateral dominant triangle method. I will start from the introductions. So in the first paragraph of the introduction, I discuss about the finite element method, how for which purposes we are using the finite element method. So finite element is the common tool and stress analysis. We use the most powerful tools, so we can use for the stress analysis, uh, which enable the design uh, mm, enable the optimal design by combining mathematical optimization computation technologies. So this method is good as compared to the trial and error approaches because it's efficient and it's reliable as well. The results are very reliable and also take less time as compared to the trial and error approach. So there are various ways we can conduct the finite element analysis using the software or equations in Python. So 1D, there are 1D element, 2D element, and 3D elements. So out of them, the 1D element provide the simplest method, the simplest method, and fast as well as compared to the other method. But the disadvantage of 1D element, we can apply this method to the complex geometries where we need our critical member structure member where we needed the accurate result. So for that, we can apply the 1D element analysis. So we discussed uh, the application of 1D element analysis. So there are some application like we can use in the automotive industries, vehicle structure models. So there are different applications we can use the 1D element analysis. Overall, it can give us the good result, but local detail that can predict the accurate results. So when it comes to the 2D model, 2D elements analysis, so 2D element analysis is a bit accurate than 1D analysis. It use the quadrilateral elements with 4 nodes, 8 nodes, or 9 nodes. They're particularly useful in plans structure member like to predict the plane stresses in the structure member whose thickness is very small compared to other dimensions. The method reduces the requirement and simplifies the assembly of elements with internal nodes. It transforms the stiffness matrix and force vector for more efficient processing as compared to 3D. 3D. So when it comes to 3D, so 3D we can that could provide us the more details of the structure element in stress predictions like we can use in this uh, CRM 25 nuclear power plant under design basis accident and seismic loads. Over 2 million of solid element incorporate foundation flexibly through linear springs. So we can employ this 3D analysis to the uh, over 2 million solid elements. So the approach uses 3D solid element to model the role of shear response in a flat slab, accurately capturing the gradual decrease in concentrate contribution to shell resistance with increased slab rotations. So overall, 3D element analysis can give us more detail, but it is time-taking process. It takes too much time while calculating the stress predictions. So we need to save the time as well as the accuracy. So for the purposes, we are going to take the 2D analysis in the study. So when the second paragraph explain the materials that we use in this article. Polycarbonate is a versatile material we can use and sheets, building products, and also a lot of roofs, towers, windows, lights, external LED. These are made from these materials. Why it we use? Because of their lightweight. We are using this material in most roof, tower, and panels, wall panels, and lights. And also it is high compact. It is uh, because of this toughness and impact resistance. We use this material in the above applications. Polycarbonate is a reliable choice for many construction and manufacturing needs because we can use in roof wall glazing because of the good optical properties as well as the toughness and thermal stability. Optimizations and stress primarily involve techniques and methodologies aimed at minimizing stress extraction engineering. There are various optimization techniques like we can optimize the stresses and structure member like we have bidirectional evolutionary structure optimization. We have the interior value extrapolations that improves the stress evaluation accuracy in jack structures. To improve the computational efficiency, we use the first order approximations as compared to the zero order approximations. So then the fourth one paragraph is explain there are various ways to approach the problems. Like there are traditional ways to approach the problem, but we have DIFI framework. This is the new approach to solve the problems. So Diaphragm consists of five eyes. The first eye represents the initiator, which fully focuses on the I am my consciousness, unlike traditional methods, which is the logical and step-by-step approaches. But this one is integrate the ethical, spiritual, and technical considerations we can that can benefit the personal, local, and expert. So while following this new framework, and the second eye represent the initial thinking, the third eye represent the which initial thinking is to collect all the information related to the problem, like open brainstorming, idealization. We can reduce the problem into simplest form. The last one I represent the actionable steps, like how we can we follow the step to achieve the, s- the step by steps instruction that we can follow to achieve the our goal. So this is all about the DIFI framework we will follow in this tutorial. Now we will discuss about a more detail about the 2D elements and as shell structures. Like there are other three-dimensional, one-dimensional available, but we will choose this one because this one can provide a balance between the time as well as the stress prediction and finite element. So 2D, why we choose like more? There are many structures like flares, thin shells, and pressure vessels that need to be analyzed to predict the stresses without using the 3D analysis. So this is the best approach we can use for the 2D shapes. The 2D shapes are like I discussed, like flares, thin shell, membranes, pressure vessels. So we don't need to model the 3D model of the whole pressure vessel. So we just draw the 2D model, and then we just analyze the stress analysis. We just perform stress analysis on the 2D geometry. 2D elements offer a significant computational advantage. These limitations necessitate advanced method to ensure accurate simulation, particularly in complex local uh, scenarios. Sh- So, two shells. Shells are widely used in various industries, including aerospace, energy, chemical, and civil engineering. So the advantage we discuss here is the advantages of the 2D elements and a shell, and also talking about the shell as well, 2D structure as well, where they are using like we discussed, like we are using the shell and aerospace industry, energy, chemical, and civil engineering. Like uh, we also mentioned some structure like aircraft fuselage, pipeline, reactor, and compartments. Uh, we are using these shells. The use of finite element method procedure is common in analyzing structure shells as compared to the true 3D. 3D makes a problem more complicated as compared to the 2D. So that's why you choose the 2D shell element analysis. And this the last one, the second last paragraph shows the objectives. Like we will perform the 2D stress analysis on the structure still made of the polycarbonates, and we will just change the input parameters like mesh sizes and mesh methods while maintaining the remaining input parameter like length, boundary condition, and thickness, and polycarbonate and the force as well remain constant. The, the last paragraph shows the problem statement which addresses the challenges facing the um, while getting the optimum solution for these 2D plane stress structures. So we this is the like Like normally, if we perform the 2D stress analysis and 2D structure, we don't know what will be the combination, the good combination, the efficient combination, the input parameter like mesh configuration, like mesh in mesh size, mesh method. What will be the complete set the of mesh size and mesh configuration, mesh method that we achieve the balance uh, results of efficiency and accuracy, time balance and accuracy. So this problem statements need to be this problem should be resolved. So that's why we choose this topic to resolve the issue related to the input parameter, the optimal input parameter to predict 2D stresses and the 2D shell structure in polycarbonates. Methodology. So in methodology, we start from the DALI-5 framework. So in the first, we will initiator. So initiator is the author who initiate to work on the problem and fully focus on my consciousness. He also has intention as a he want to enrich his knowledge to also which also benefit the local as well as the expert, not only one. He just want not only spiritual benefit but also local benefit as well. So the author use the DIFI framework, so that will lead to the success of this research. Intention, intention. What is the intention of this objective of this study? So it is um, uh, true context. In the context of the technical perspective, it is just like 2D stress analysis and 2D structure to minimize the time as well as increase the accuracy. So we can get a good result of stress. And on the other hand, a non-technical perspective, the other intention is to facilitate the local communities, local experts, so that the the local people are is not facing the challenge, the problem related to the um, structures like maintenance cost, energy, like when they like for the expert, if they perform the stress analysis, they will just they will never know like what will be the optimum combination of parameter that we can achieve the best results. So the other intention to resolve those issue related to the technical perspective and as well as the non perspectives. Initial thinking. Initial thinking is the brainstorming, like the components of the problems. So we already discussed the component of problem as well, but here we discuss a little more the 2D element about the 2D element analysis conducting on the cylindrical shell made of polycarbonate, which is the hard top and impact resistant and thermal stability. So we talk about the element, we talk about the 2D element. So nature of problem is like we discuss about the nature of the problem. So the nature of problem is we are going to conduct the stress analysis on 2D structure under uniform force to understand their behavior under studying loading conditions. So the shell is question made of uh, polycarbonate because of the good properties, mechanical properties such as toughness, resist, and thermal stability. These properties makes polycarbonate an ideal choice for the application requiring structural integrity under various current loads, including pressure vessels, pipes, piping systems, and storage tanks. So this is about the nature of the problem. Stress analysis, like we have different types of stresses analysis, 1D, 2D, and 3D. So you choose the 3D, 2D element analysis. The primary focus is on the understanding the how the plane stress is distributed within the shell structure. Specifically, the goal is to assess how the polycarbonate material respond to the applied forces. We'll calculate the x and y direction stresses, 2D stresses in the shell made of the polycarbonate. Idealization is just make the problem simpler. So the main aim of idealization is to make the problem simpler, like we choose the material polycarbonate because we have different types of materials. So we choose the um, material that is a polycarbonate, and also we we assume the problem is shows the elastic. We assume the problem should be up to the elastic range. uh, we following the Hook law as well, like it is given by the equations. D represent the modulus of elasticity, and E represent the strain, and sigma represent the stress. Then apply the Excel stress transformation equations while putting the excluding this term like sigma z 0 to, because we make the problem simpler to 2D problem. This is the 3D equation, so we reduce to the, if we want to reduce the problem into 2D, so we made these three terms to 0. So I will get the problem simpler, like the same in here. So the stress equilibrium equation is by the given equation are stress equilibrium equations. So if we put them 0, so we can get the simpler model of this form. uh, and then we choose the 2D element analysis instead of 3D analysis to make the problem very simpler. uh, then we choose the dimensions, like there are various types of dimension, but we choose this one. So this is all about in boundary condition. In boundary condition, we takes through edges of the shell, um, two edges to text, and they applied in the middle of applied load of 100 Newton at the middle of the shell structures in the y direction, negative y direction. We put the constraint, like instead we reference value of 0.3 mega was selected to calculate the error in normal uh, stress in x direction, serving as a benchmark for the evaluating accuracy across different mesh configuration. So we choose the 0.03 megapascal um, megapascal stress value for the x direction to calculate the optimum result, as well as the time constraint as well. 13 second is the constraint. So we can achieve the best combination of input two input factors like mesh size and mesh method to get the best optimal result. Instruction sheet. Instruction sheet explain the step-by-step instruction to perform, to reach the goals, to solve the problems. So the first step is to make uh, we are we are going to perform this 2D stress analysis in a polycarbonate shell structures. For that we need the geometry. So the first step is the using ANSYS software. So the first step is the model. See, we design the model in the ANSYS software of the dimension is 515, length is 500 mm, outer radius 50 mm, inner radius is 45 mm, wall thickness is 5 mm. So this is all about the model geometry. And then then the second step is this material selection. We choose the polycarbonate, and these are the properties of the materials using the ANSYS library. Meshing, then we generate the meshing. We tried the different types of meshing, like methods like multi-zone quad the triangular and quadrilateral dominant. So we applied three methods. Also we choose the element size 1 mm, 2 mm, and 3 mm. This is the result of the uh, quad trie with varying element sizes. Like if we choose the quad trie method, the 1 mm size, it shows like even the meshes are very fine. It then it is a little bit coarse, then it is more coarse than the other two. So the same way for the quadrilateral dominant method, like the if we choose the element sizes too small, so it shows the fine means it so the coarse is also the coarser than the other two. Same for the triangular method, like you can see here in the picture. So boundary condition, then we set the boundary condition. You can see in the picture, like we fix these blue color edges, this one we set this, we set the fix, and we apply the 100 newton in the y negative direction. Then we solve the problem uh, while choosing the NC solver. It give us the stress in y in y x and y direction. And this is the flow chart how the the flow chart of DI5 framework. You can see that start from the initiator, then intention, then initial thinking, then realization, then instruction set. So in the last one, sorry, I didn't include this one. I think I here included in the main wiki page here. Idealization. That's sorry. This is all about the this one letter. And you can see here I included the picture, the flowchart for the stress as well, how the NCs work. Yeah, here. So how we can in NCs calculated FEM. So this is about the flowchart of the FEM. So you can see here, then model, we design a model, then we define the material properties, then mesh size, mesh method, then we divide the we create generate the meshes, and then it solve the problem, and then in the last we get the stresses. So that was here I didn't include it, but I will include it. I think I forgot to save the options, so that's why I didn't include it here, but in the wiki page there that are already available. So no problem. This results and discussion. So these are the results obtained from the multi-zone quad trie method with 1 mm element sizes. So now this is the pictures you can see for the 1 mm size, for the 2 mm size, for the 3 mm size. This is the time for the multi quad trie method. And this is the quadrilateral method with size, 2 size, 3 size. And this is for the time for the quadrilateral dominant method. And the last one is the triangular method with various sizes like 1 2 3 and element for the triangular method, time for the triangular method. And this is the discussions about and what we saw here. So we saw here, like if we choose the element size is 1, so the mesh size is uh, uh, like this is for the this is for the 1. So you can see it is more high as compared to this one. So it means that, like if we increase, like you can also compare this one and this one as well, 2.45, this is lesser than this one. So it means that it give us the, if we increase the elements sizes, so the result or prediction of the stresses is less as compared to the one here less element sizes. You can see here, you can see, and this is the time taken by the 1 sizes, time taken by the 2 sizes, time taken by the 3 sizes. So time taken because it give us good result, that's why it took time. Then after that one 2 sizes took time, and then after 3 took less time because it is simple to solve. So for the same for the quadrilateral, you can see the values are lesser and lesser when we increase the element sizes. If we compare this one 2.8 to 2. Um, uh, 2.48, so it is almost lesser as compared to the 1 sizes. And the time taken, this 1 size, as we already discussed, like 1 sizes takes too much time as compared to the other remaining two element sizes. And this is for the triangular. The same case for the triangular, you can see here the results are available 2.48, 2.45. So it becomes lesser when we increase the when we coarsen the mesh. So this is the time taken by the triangular method. This is we discuss all about here. uh, these discussion. Then we now we need to calculate the optimum combination of the input parameter that give us the good best result. We took the constraint 0.03 megapascal to in the x direction for the stress and x direction to calculate the absolute errors for misconfigurations. And the same way we choose the 13 second uh, 13 seconds uh, to calculate the minimum and minimum to threshold to classify the time as either minimum or maximum. You can see here I put 0.03 second for this one, 0.3 megapascal for this one. To calculate the error in x direction as a like as a constraint, right? So as a constraint I calculated error for this stress, and time for the time I choose the 30 seconds. So I then uh, calculated the time minimum times and assign the classification minimum and maximum. So you can see here I choose the 13 seconds. So within this, if the values less than 13, so I assign those values as minimum. You can see here 12.5 as minimum, then 30 second you can see minimum. And if it is more than 13, so it is, you can see here it is maximum. Now the time is minimum maximum. Now we will see the error as well. So if we see the time here, which is the lowest time here, fell. It is 17 point, the error is 17.6, right? But still we can see here there is one 17.3 as well and 17.2 as well. If you look at these two values, 17.3 and 17.2, but it takes time as well, like more than 12 and 17 is more difference. So that's why we rejected this one, right? And when it compared when it comes to the 17.3, so it also takes time more than the this one, the error assigned to this one. So the error is also near as compared to the time. So we choose the 2 mesh sizes and multi-zone quiet try method as the best optimal input factor for the prediction the stress. So this is all about the mesh configuration optimization and mesh configurations. We choose this setup to uh, the best optimal input factors for the stress. Conclusion. So this is and this conclusion is we summarize the whole scenario in few lines. Like we discussed the multi-zone quad try method give us the accurate result at 2 element size, that capturing the more details than the other two element sizes. Then the quadrilateral dominant method offered Consistent stress accuracy, like the accuracy is consistent when it comes to quadrilateral dominant method, but it takes time. So this is the main problem with the quadrilateral dominant method. The triangular method give us more details, more detail the other two method, but the problem with this one is it takes time. So we need less time and accurate result. So to trade up between these two, the best option is quad, tri, and multi-zone quad-tri method. So this was all about while applying we achieve this goal while applying the DIFI framework. Otherwise, it will be difficult, hard to get to the reach the problem. So while following the DIFI framework, step-by-step procedure, so we achieve our goals, objectives. So this is all about the 2D plane stress analysis in 2D structure, the optimization of the mm, mesh configuration in 2D structures, 2D analysis, 2D analysis in 2D structures. So this is all about this article. These are the references. So thank you. If you have questions, you can put comment in the comment sections. I will definitely answer those questions. So assalamu alaikum warahmatullahi wabarakatuh.